All right, I'm sure you guys are set. Yeah, I'm sure grab something. All right, good evening, everybody. I think some people are still joining online. Thank you for waiting. If you are online with us and in the room, we had some technical difficulties this morning, but hopefully everybody is ready to get started. So today, thank you again for joining us this Wednesday for our IEEE IES Atlanta chapter meeting. We are thrilled to welcome Deepa Pahuja as our Senior Solutions Architect at AWS for her distinguished technical advisory role as the Chair of IEEE Computational Intelligence Society. Deepa will be presenting today on powering the future, accelerating energy and utilities, transformation through cloud-enabled solutions. And we're looking forward to networking with her and learning about this cutting-edge cloud infrastructure in our industry. And thank you for joining us. And without further ado, I'll turn it over to Deepa.
Thank you, Carlos, and thank you all for having me here. It's been my pleasure, and I'm glad to talk about how we can accelerate what we are seeing as a huge transformation in the energy and utility space through cloud-enabled solutions.
I need to click your mouse on the center.
Okay. It's not working. Oh, it works. Apologies. Apologies. I was just testing out the clicker. So as you all can see, I'm a senior solutions architect at AWS. I've been with AWS for 7 years, overall 12 years of experience. And I've done my Master's of Science with Georgia State in Information Systems. And apart from my professional experience, I'm also volunteering with these organizations. As you can see that I'm a fellow at the Energy Institute. I'm a senior member with Power and Energy Society. And I'm a tech advisory chair with CIS. And I'm looking forward to actually working more closely with Carlos and team on the IEEE IAS Society as well. Really excited to be here. And let's look at what we're doing in this space, right? What we're trying to do, expanding energy landscape. What does that mean? The technology is changing, the players are changing, the way we deal with energy, the way we distribute energy is changing. So a lot of this is evolving. There's a lot of new challenges that we're seeing around us, right? And with that, we have a very complex integrated energy value chain. There was this time ages ago, I would say, where we had power being generated at one place, simple distribution, direct lines transmission, and the customers would just consume it. Now we have distributed energy sources, wind, solar as intermittent sources. That's where energy is being generated and distributed. And now we have new storage solutions into the mix. So we have to think end to end on how to navigate this complicated energy chain. With that, we have evolving customer needs. There was a time when customer was fine with just paying one monthly bill. Now, how many of us have those smart thermostats in our homes, right? How many of us electric vehicles today? So all of this is changing. But one thing is certainly clear. With all of these evolutions, we have one clear path to do. We need to come together as reinventing energy together. We need to innovate and move fast so we can accommodate the new evolving needs of the customer, and we can provide them and make sure that we have affordable and secure energy for everybody. If I go a level down, and if I just talk specifically from the power and utilities point of view, you all can see that we have now varying EV needs. International Energy Agency predicts that we'll go from 16 million to 140 million vehicles by 2030. Imagine what that means for the power grid, right? We have unprecedented demand that goes to some of that grid instability. We have these terms with distributed energy resources, which I just talked about, wind, solar. Now we need advanced monitoring. How it changes, Earlier, we were just consuming. Now we can also give power back, call them as consumers. So those are consumers, but actually they can also produce if they have more power with the solar at their rooftop. We also have customer expectations changing, like I just said. Now you want smart billing. You have demand of these solutions and you want them now. So you want real-time visibility, aging infrastructure. We have, if I just take one example, 70% of our transmission lines are already 25 to 30 years old. And we have aging infrastructure with AMI, the metering infrastructure, which are very near to the end of life, and we have to upgrade them to AMI 2.0, which could do advanced monitoring, which could get this data from that little meter box that you see, be it commercial and be it houses. So all of this is changing. And all of this are challenges across the value chain. If I just look at it from the market trends perspective, we are doing electrification of almost everything, right? From looking at intermittent sources, but providing enough new business models, providing energy storage options, then looking at the infrastructure security and resilience. We need to make sure there's robustness of energy supply. There's enough energy in the mix that can meet everybody's demands. We all know what's happening with the rise in AI. We all know how we have to work a little more extra in terms of making sure that the environments have cybersecurity enabled. I see. I'm here with a smiling because some of us are facing this day to day. On top of that, we have to decarbonize customer energy usage. We have to make sure energy is more efficient, but it has carbon management solutions. So the decarbonization is in the mix. With that, a very important factor. Now with EIA, it's also talking that the global demand of energy is forecast to double. And with AI coming into the mix, there's more demand for data centers, there's more demand for doing more and more AI. Every organization today is looking at how they can use AI and agents to transform the way they operate. And also with the report that IEEE published, all of these companies are also trying to target towards the net zero emissions by 2050. What does that mean? You need more power. You need more clean power. You want to do more decarbonization. On top of that, you also have to meet your net zero goals. So challenges, 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 and we have to find the middle ground. How do we solve for it? Digital transformation. What does that mean? So when we are trying to solve for these 3Ds, decarbonization and decentralization, digitization is what comes in and can help with these need of the hour. When I say that, just flexible generation. What does that mean? That we can get all of this intermittent sources of energy, which cannot be predicted. You cannot always predict that the sun will rise at the same time and you produce the same amount of energy from solar. Yes, there can be some prediction models, there can be some weather forecasting, there can be some simulations, but we'll know for sure that those will be intermittent, right? Those are not like the power plants nature that we've seen traditionally. Flexible delivery. To be able to optimize energy trading and delivery so it reaches wherever it's needed the most. On top of that, talking about flexible demand, right? So we just talked about customers have this new demand and they want things different ways. So making all these different accommodations for utility value chain across from generation to distribution to transmission to ultimately end customers, we have to make sure we look at this digital transformation that can ensure that this flexibility can happen. We can move with the pace of changes that are coming out of it, right? And when you do all these different changes, this allows for greater focus on core utility objectives that utility want reliability. We want to give power for all. Especially for some critical operations like hospitals, we never want them to go without power, right? We want to make sure there's safety and security for everybody. We want to make sure it's at affordable prices, right? And customer satisfaction is no-brainer. So what does it mean? Let's look at what we were doing yesterday and what we are actually doing tomorrow or even close to today in some areas. We had large power plants before at centralized locations, mostly national. You could almost predict that we have these many power plants in these many areas. Now we have many small power producers everywhere. Even somebody, I was literally watching a video on how people with the entire solar roof are able to even produce power and give back to the grid. So we're not able to keep track of everybody, but we need solutions to be able to do that. Then we have these centralized, mostly national players, but within the market now we have these decentralized models. We are not relying just on those regional transmission officers. We have this distributed ways of generation, and now we need to have smarter ways to make sure the power, which is maybe is being generated in Colorado because it has more sun, it can also reach areas like Seattle where it has less sun, right? We were talking about transmission, these large pipelines, large towers that I remember seeing from childhood, right? And now we're talking about these small scale transmission systems, regional supply compensation. Did you notice one thing? Now we have this energy storage in the mix, which needs more materials actually to be able to grow these batteries to be able to store this. And initially, distribution was one way. Now, like I'm saying, in both directions, you can even give back. Passive, only paying monthly bills. Now customers want active participation. They also have ways to store power on their own systems. I remember only like few years ago, everybody started building these outhouses, small offices where they could just use solar batteries to power their daily usage for what's required to work from laptops, right? So this is the way we're changing. We are looking at 3Ds, digitization, decarbonization, and decentralization. And that's where AWS is empowering the digital utility of today. We have solutions, customer activated and partner solutions across the value chain when it comes to generation, transmission, distribution, and even customer operation and modernization in some cases. Very interestingly, one common thing that becomes the baseline for all these kind of solutions to make this happen is data. This has always been the case, right? We try to do smart intelligence across multiple industries, but in energy, it has become all the way more important. There were times people would just be hesitant to put their data on cloud, but now it's becoming a reality that with the right security and governance controls in place, you can unlock those insights from data. And you can get those intelligence real time where you have power, where it is more, and where you have less power, where you want to make sure the power reaches. Or even for running smarter solutions for predictive maintenance, or even running those hundreds of simulations for making sure we have the right energy forecast, or even making simulations for the right kind of transmission models, or how that energy gets traded in the market today. So that being said, we have 200 plus AWS services. The breadth and depth of it is huge. But stating, we are looking at some core services where we're talking edge. That means we can collect data real time from these equipment, from these power plants, and give them insights there and then only. So we, of course, relying a lot on AI, ML, Gen AI type of capabilities, and I'll show some quick demos, examples in the end. And also for Lex, like intelligent services, Amazon Connect, which can help you with this customer sentiment analysis, right? Because the customer experience is key to what utilities do today. I think this is a slide that everybody can relate to. We have been doing video streaming. We have been doing drone development. This is just an example of what we've been doing in terms of historically, we've been innovating all over, right? Across multiple businesses. And that innovation continues to guide us on what are our innovating principles and how we continue to innovate for energy and utilities customer. Now, switching gears to a little bit of what a modern digital business would look like. And why? Because there is this era of change. There's the way typically models would operate, it's changing now. How enterprise models and how enterprise IT systems would look at what those utility companies, right? And in terms of a modern digital business, you would of course need to be organized for value. You'd need to be customer obsessed, giving them the right experience. You need to have technology at the core. The learn culture stays at the heart of it, but there needs to be strategic use of data. And this is where it makes the most sense. Initially, if there were times when you would have highly regulated domain, everything in one box. These were the plus points. You can put as much controls as you would put on it, but it would slow the decision making. The fast pace, the kind of door integration we're talking in the energy world, we cannot slow down our decision making. We need to make decisions fast on what's the contingency analysis if a transformer in that transmission route is not going to work. It needs to be that good, right? And if we do it in a decentralized form of way, we are limited, we are very limited control. There's no easy way to understand what lines of businesses are trying to do with the data. That's where comes this modern data strategy, where you have producers. We need to have incentives so producers do enough data producers, and then consumers make data models out of it, which make value for these energy and utility use cases. With that, so now we have the data foundation established, whether it's grid data, whether it's simulation data, whether it's market data, whether it's power plants data, right? For even equipment, for predictive maintenance, all of that. What value really comes out of it? So we just looked at that there's business transformation all across the value chain for energy, right? And now you might say this is a very heavy slide. It has a lot of context in it because, and it's intended to be that way because within, you could do trade anomaly detection when it comes to energy forecasting and trading. You could do remote inspection for predictive maintenance. You could do automate reporting on some of the outages that just happened in a utility, and you could take photos and you could ask it to, like, now with the generative AI in the mix, you could ask it to generate a report of the actions taken. And then we can feed that information back to the machine learning models to learn. So next time they know how to act on it and provide the right kind of recommendations. Grid operations advisor, asset planning. So there's no shortage of what we can achieve and how we can power the grid and make sure there is secure energy for everybody at affordable prices, right? Now, if I go just in the layer for generative AI for energy and utilities, there's a lot that we can do from customer engagement to operational technology to energy supply, which also has a little bit of an overlap with decarbonization, going from asset performance to trading and even IT performance, IT transformation, right? All these use cases are totally doable. Now, and this is something that we've been doing with customers across the world, right? Now, let's look at some use cases and see how that makes sense. You need to do maintenance enhancement for some motor running in some environment. What would you do? Traditionally, those issue occurs, somebody flags it. Oh, there's an issue. It cannot continue to work the pipeline anymore. You do some manual research, find a potential solution, try to work on it, may work, may not work. Go back to the cycle of manual search. Now, today, with generative AI, you have all of this unstructured data. It's easy to say this is unstructured data, but for the operators in the field, it's a lot of manuals, 500 pages sometimes, detailed technical drawings, engineering specifications that they have to go and find about particular piece. That integrations happen with a large language model, and then you get the validation of a solution. And it also even point to the resources where it picked up that information from. So it can even talk about how that changes on what you're doing in terms of maintenance today. So it increases the solution quality because it found it through valid sources, and it also increases efficiency through faster solution. And then you can get back to these equipments working better and faster. And one plus point, it also saves the operations and maintenance for all these fields. Sometimes it takes millions when these O&M operations have to happen for actual wind turbines. I don't know how many of you have visited one. But they have to take a big cart, go there, it's thousands of pounds of blades on a wind.
Sure.
And even for power plants, right? There's hazards and there's so much more. Now, within the same example, as a human, how difficult it is for us to read this. And how difficult it is for us to read this. That's what GenAI can do for us. And with that, it can even categorize, summarize, and give us an actual list of actions that you can just convert them into a work order. So you can automate the entire workflow from that point of view. It can even integrate with IoT. What does that mean? Internet of Things. So when we have these equipments in a manufacturing facility, in power plants, we have this bits of JSONs. I don't know how many of you have seen JSON documents. That's what in this slide it looks like. This is what it looks like. Sensor data, this is the timestamp, this is the motor ID, this is the rotations per minute. What do I do with it? And not everybody can make sense of JSONs at all times. Generative AIs make it easier. RPM of 2500 is higher than the rated speed of 1445 RPM. That means if you continuously put load on that equipment, it could fail. It might stop the power generation, or you might need to look at alternate sources to do that. And when it took your sensor data, which is real data coming from your live equipment's motor at that point, it also validated this because there is a basics, maintenance, and diagnostics information on the transformers document. And it saved you so much time. And it'll even point to the source that it looked at this document. You could have 25 documents every day, but imagine going manually and doing all of that. So it's a very simple use case, but see the impact it creates.
All right, question.
Yes.
So I assume, like with me about just switchgear, automation, protection and control, that you are advocating putting digital merging units in the switchgear, removing the protective relays and putting that protective function in the cloud at AWS, right?
I'm not saying put the protective functions in the cloud. All I'm saying is when these operators are working on these real time, sometimes they just lose the time trying to figure out what the problem is.
Yeah, but why wouldn't you do that? I mean, why wouldn't you build all that protective feature into the cloud? Then that way you don't have to deal with, operators don't have to deal with.
You can certainly build, but
Yeah.
working with these customers in the field, there are use cases where it's okay to have these solutions in the cloud, but where sometimes there is some critical infrastructure protection rules, and sometimes there are guidance where it needs to be closer to the grid. So in that case, there are ways you can train your entire IML model on the cloud and deploy it on edge for inference, where it's closer to the grid and it's giving you those answers. But this is a very simple point where it can happen closer to the field operation.
Okay.
With that, this is just an example on the kind of sheet that looks like, which could be immense in terms of number of pages, and that large language models could translate it, understand it, and even generate a response to it. Another use case, call analysis. The reason why I picked these two use cases because we know how critical it is for power and utilities to enhance customer experience, right? So foundational model would ask these kind of questions. Should the agent resolve? And in this case, agent is actually the human agent that's taking customer calls and trying to do resolution. What happens is we're asking questions to this agent. Did the agent resolve the customer request? Can you give me a summary? What could the agent have done better? So typically they take hundreds of thousands of calls over months, right? And it's not easy to go back and manually transcribe all calls and do the analysis. With this type of generative AI models, you can get all of those analysis done in a matter of minutes. So it can look to the transcription of the customer calls they had and tell you if overall the customer sentiment is positive or negative, or what else can you do to fix it. So an example solution would look like this, where you just drop your .wav file, which is that audio file, and you can ask it to generate a sample output. You can even select a language, like, hey, give me a summary in Spanish on what the customer called and what the customer sentiment was. Now, with just those two simple examples, what we are seeing here is we're taking a step further. We have seen enough use cases where we are integrating traditional AI systems with generative AI on day-to-day basis. Even a small minor step that is repetitive, where you need a lot of time manually spent, you can automate that with generative AI. Then there came a point where every industry, and specifically within energy, we want to build this domain-specific LLMs. How does that help? When we build this domain-specific information, suppose you have a foundation model, which typically gives you generic answer, fine. But now we've given it enough data, we've fine-tuned it, we've given it information about how does this happen in the grid operations, how do we do these maintenance, predictive maintenance every day. With that, because you have a domain-specific LLM, it's much cheaper and more accurate answers you get. So you save on cost when you're getting these answers through the LLM models, but you also get more accurate answers. So this is another trend. Now, where we are today, we are seeing more and more customers, more and more energy and utility leading providers getting into the world of using agentic workflows, where we had agents which could do specialized work, but now with multiple agents working together in a hierarchy or multiple architecture patterns can build these automated agentic workflows end to end. One could be, for example, in energy trading workflows, you'd like to analyze the chart and come up with recommendations of what could the next bidding be, or in the transmission sense of the word, you could do some simulations. You would still rely on the same high performance computing technology to do those transmission simulations, but at the end of it, you could have Gen AI and have some agents come with some specialized expertise, do it as an end-to-end workflow and generate a simulation output response on what could that bid be. Or if they need to do any upgrade in that transmission route. What does this allow? The examples I'm taking, this allows energy companies where they have more power to build faster, to be able to move power faster in the transmission cycle and make it available to customers like us faster. Right? And as exciting it is to do a lot of this AI and Gen AI, it's very important to stay on top of the responsible AI dimensions. And when I talk about it, like we have to have explainability of what these solutions are, what are the sources of truth. There is fairness in terms of what type of impact that's going to be on different types of stakeholders. And we have solutions where we can use guardrails. We have to make sure they're safe solutions, they're preventing harmful system output and misuse of these systems that can just go wild and do a lot of it, right? So you have to have the right, every time I talk about generative AI in industrial conversations, I definitely bring responsible AI because security is step one, right? And in the Gen AI world, responsible AI is how we can use these systems and put them for the right use. Now, with a little bit of those examples and how what we're seeing and how what's changing in the industry, there are a few examples on what real customers have done, and all of these are public. You have case studies. Greenco, one of the renewable energy companies in India, which have capacity of 7.5 gigawatt and they're expanding. They had a challenge where they wanted a consolidated view across the data fleet, right? They had aging IT infrastructure. They did not have an easy way to collect data from each of these equipments, put them in a asset hierarchy, ability to understand and put them on dashboards and whatnot. So they looked at AWS IoT services. They hybrid their IoT data lake, which has an easy way to connect to your sensors, get all of that information in one place. And within that data lake, they were able to create dashboards, which could be refreshed every minute. They were able to easily get information for 1,000 plus wind turbines, which was almost impossible for them in the world prior to this. These are actually some of the customer quotes where their vice president is sharing that how easy it is for them to now bring power plants, operational data, and have visualizations and dashboards on top of that. If you see some metrics that they have been able to ingest 70,000 tags per minute with capability to expand to 1 million tags. Why? Because their systems are built with scalability in mind. They're able to do real-time dashboarding and analytics with field to cloud latency of less than 1 minute. So in this case, if I go back to the previous tip, in this case, it makes sense to do it in cloud because it's okay to get that much latency and act faster with the field, right? Another example, we have renewable energy optimization solution that our Amazon teams are using to manage their energy generation and look at these dashboards to see where they should do more and where they should do less and where they can deliver additional clean energy solutions wherever needed. So the right optimal way of producing and distributing power. Very interesting. With Duke, they have more than 8 million customers in the Southeast. As we know, they have been serving, this grid has served us for more than 100 years. A solution where they had to run these simulations to understand the electricity needs. They had to run 17 million grid simulations. Take a minute, right? And it went from 6 weeks to 15 minutes because of the high performance computing solution that you can use underneath it. And they were able to reduce the amount of IT infrastructure that they've always had to keep up because it's in the cloud, so they can run the simulations and put them down when they don't need to. This has a huge impact on how they can make sure that they can give reliable and affordable power to their 8 million customers. NG, another example. I try to take variable examples across the globe, right? This is the one in France with 160,000 employees. What they did, I talked about the data at the center of all the solutions that we're talking. It's either asset data, it's either equipment data, or it's either data that's required to do the simulations. In this case, they wanted to develop, train, and deploy predictive maintenance models, right? And so they were able to use our Amazon services, SageMaker, for example, our AI service, to be able to create these models for predictive maintenance. And they created more than 1,000 predictive prediction models. With that, they were able, and like I said, similar to this, they could create models that knew information about walls, pumps, so it should give information faster response when you ask that intelligent system on what could go wrong, right? Predictive maintenance. So as you can see, it can save them 800,000 pounds per year estimated savings, which means a lot, right? If we build these solutions to enable the utilities and leading utility providers in the world to save this, first, it saves them time. Second, it saves them money to focus on the key core outcome, to be able to provide power to all of us as needed, right? There are a lot of challenges in the world. There is this grid that we have to make sure it's stable and secure for the world. There's grid enhancing technology that's coming up. So how do we accommodate all of that? There are new sources of energy, right? So with these solutions, we can solve the pain points with digitization, decentralization, as well as decarbonization, making sure we help them achieve their outcomes and ultimately solve the energy industry at large. One another example, it's no doubt that thousands of assets, managing them to be able to maximize power generation is always a concern for all renewable energy companies, right? We all know how that's evolving all the time, and they want to make sure they can maximize power out of it. So they were able to process terabytes of data real time from their field, able to process it and for 40,000 assets. It improved availability from what they were able to do manually before. And then they were able to unlock more about how that renewable energy operations are working for them. Similarly, one low carbon electricity producer in UK with EDF, they also wanted an easy way to transform their trading operations, and they leveraged our managed database services, because now traders were able to simplify their trading books and they didn't have to wait on like the trading system and click on it and wait forever for the next step to happen. These simple productivity pieces could mean better energy consumption for the world. Another one sounds simple, but how many of us always read news about wildfires in California? San Diego Gas and Electricity, they presented about this solution at reInvent, which is our conference, but they had these questions. How might we leverage machine learning forecasts to better prepare for these weathers? How can I look at some images? They had drones roaming around. They had thousands of images coming through. Somebody would sit and manually click yes, no, asset, yes, damage, yes, no. They started leveraging AI models to review these images and identify high risk issues faster and act on them. Otherwise, manually, somebody would just still keep filtering images before they could even go there and act, right? And they even further wanted to look at how they could use satellite images to combat wildfire deforestation. And for all of these efforts that they've been doing, they even received national recognition for wildfire safety innovation. So this is saving human lives at the end of it. One very brief portfolio. There's a lot more. We have, like I said, 200 plus services and breadth and depth of it. But from the customer experience, right? We have Q, where it can be our generative AI powered assistance based on the work you need to do. We also now have Quick Sword. We have personalized, which will give you personalized recommendations, something that powers your recommendations in Amazon when you go there and it automatically pops up what next you want to buy, right? So forecast can help you do accurate forecasts in the energy world. So a transcribe can transcribe your meetings and the customer interactions and all that. So all of these solutions collectively basically help a lot in the customer experience. Just like a one quick example of the tools we have at our disposal, and there are dedicated engineering teams that's working behind the scenes to make these tools happen. So people like us can come together, and reinvent energy and make sure we give the world that it needs, work towards a more stable grid, and reinvent energy together with the changing world. That's all I have. Thank you.
What was the predictive maintenance platform again? It was something Sage.
SageMaker, Amazon SageMaker.
Okay.
AI, it's our AI service that helps you build, train, and deploy models. And now you can even combine SageMaker with our generative AI services called Amazon Bedrock that allows you to build end-to-end generative AI solutions.
Thank you.
So we have a great solution, and one question, what's the status of this solution? What is that database? How many information gathered so far, and what is the timeline? And then I do have a second question.
For which solution?
For gathering this database. So
How long does it take?
yes, so the more information gathered, the better. So how much information we have now, and what's the timeline, maybe next 5 years?
So different utilities have different ways of doing it. There are some utilities which are way advanced, where they have all of this information available in databases. They just need a quick click to connect to cloud, right? But there are utilities which have these SCADA systems at their field. They have these sensors on like turbines, on motors, and they're giving real-time data, but they don't have a way to manage it. Right? So what we need to just come in, start putting the data in format, what we call as data lake, and start making sense of that data lake, creating visualizations on top of that. Because all of the data is no use until you make decisions out of it or make dashboards out of it, right? And there are a lot of national renewable energy laboratory. They are creating some public data sets for some of us to collectively come in the community and experiment. There is some open forums where they're giving us some weather data. So we have a lot of open public data sets available, but for making solutions like these happen with actual customers, we sit with them and see what data they have. If they have data, we make them connected to the right sources. If not, we help them connect data. For that, as I mentioned initially, especially in this energy and we have regulated industries, right? We have critical infrastructure protections. We have to be very careful of the cybersecurity measures that whatever is in their box is in their box.
Yes. So there was a couple of really great examples. So I think as these services available, they come and then it's going to be added to those. Means like maybe 5 major clients, but hopefully it's more coming and hopefully
Yes,
because the more information, better.
yes, this is a very small list of what all we're doing with so many customers. I just came up to a variety of use cases on what all we can do. And like I shared in some previous slides, there's 25 to hundreds of possibility of what we can do, right? And what we need, like together as a community energy industry, to start believing in this, start working towards it to make it real. So utilities can focus on critical issues like some hardware, right? That aging infrastructure, that's not in my control, that's not in your control. We have to work on either enhancing technologies that some of the existing transmission lines can be more efficient. At the same time, we have to work on easy models so the newest generation can be replaced without impacting some existing power availability, right? We don't want if a transformer is getting replaced somewhere, it blocks out the power for the entire community. Right? That's not the world we expect to go into the future. We want to give secure energy for everybody at affordable cost. And that's where we as technology and myself as a solutions architect working with these leading providers to work on these solutions in this case.
That's good. I have a second question, but no, go ahead.
So I remember towards the beginning, you had the how the grid can go both ways, bi-directional. How? Because I know I'm sure a lot of utility companies are like, we only sell power. We're not going to buy power from you. So like, how reluctant are they these days? Because they will fight back and say, no, we only sell stuff to you. We're not taking it back.
There is a business model on how, that makes it beneficial, but then there is a reality. With this distributed energy resources in the market, and there are times where actually load becomes too much. And if there are people producing power within their homes or some commercial operations, they can give it back to the grid. And grid operators are actually open to that now. Because sometimes they are short of power and those sources can actually help accommodate those needs. It's both ways, right? And this is how the model is working today because the power mix is changing, the generation mix is changing, and it is the need of the hour that we have to integrate, right? Yes, we can just still rely on some of these traditional oil and gas and fossil fuels, but until when? Right? You have to make sure these clean energy mixes are well into the mix. And there is an easy, even though I would not say it's an easy change, it's a complex mix of this new landscape now. But we have to have solutions so we can monitor wherever there's more power, it can reach.
So I guess they're willing to step up and be more open, not coldly. Because I guess they'll have to eventually.
Yes, and that's where when I go to these industry conferences, that's when I see that change is evolving now.
Sorry, you guys were saying. No, it's fine.
Any other questions? So another question is, who's responsible for accuracy? I think I was mentioned now, after having this great information, this great solution, you want to make a decision based on that, or maybe even connect it in future to the control
Yes,
and protection.
Yes.
So who will be charge of the accuracy of the information that going to be used for certain decision, and then kind of how to kind of record that if something go wrong?
yes. So there can be two types of operation where we automate it end to end. We have tested it enough. We rely on the recommendations and we want those workflow to happen automatically, right? It could be like fixing one image in one side of the turbine, some thermal coating or things like that. Another one where we have these intelligent systems to give us recommendations, but having a human in the loop to validate and then act, right? And depending upon the severity of the use case, the problem that we're solving at hand, it definitely makes sense to have humans in the loop to validate, right? But if it's like typical day-to-day operation where somebody goes up and takes 5 images and creates a report of what they changed, so they have historical information. We really don't need anybody to validate, it's just a matter of logging, but it can save them a lot of time. They could have a camera on their head and just keep logging, and all of that could be created into a report automatically. And they could get those hours saved, they could save the money that takes them to do the trips upward, and they can solve more critical issues in the field.
Thank you.
Any questions from folks online? I can't see it, but I don't see it.
There's one thing that's also interesting. I saw like Amazon Translate. And I was like, I never really got to that. I've never seen I've never seen that one before.
We have that. I'm actually helping customers use that service. In fact, today when it comes to generative AI solution that helped me look at my meetings, transcribe the events, like send a quick summary of my meeting, it will use that simple example here.
Because I know it's not like, because of what, like translate.amazon.com or something. Yes, I'm guessing it's that.
Transcribe, yes, that's
Transcribe.
that transcribes your audio. There's a lot in this space. There's Amazon Poly, there's Amazon Lex, which can act as an agent to interact with the customer. So there's a lot. So these are the turnkey solutions which are ready as services that you can use out of hand.
Great. Any more questions? We can close out. Thank you again, Deepa, for presenting for our IEEE chapter. I think we do find great value in the information that you presented. We can agree that AI makes our lives easier and that we're looking to see it integrated more in the power utilities, more in the data center life, the everyday type of work that we all do here. So yeah, on behalf of IEEE, I did want to present you with a small token of our appreciation.
Thank you. Thank you for having me.
And thank you guys too. We had some technical difficulties with us. And if you do want to find Deepa, this is her QR code.
That's the CEO.
Okay, yeah, we'll her QR code, but go. Yeah. Thank you.
If you're in person, please scan that. Or if there's